Welcome to the first video tutorial from Ceetron. In this video I will show you how to create an application from scratch to post-process NASTRAN and ANSYS simulation results and share those results in PowerPoint and on the web. My name is Fredrik Viken and I'm the CTO at Ceetron. First I'm going to give you an overview of the application we're going to create today. It's called MiniPost and it's going to have a very simple user interface. I'm going to be able to open NASTRAN and ANSYS simulation results, or actually any result that is supported by our import CA library. I'm going to add toggling of the mesh, or the element mesh. I'm going to show you how to show a scalar and vector results. We're going to add a cutting plane with the clipping with the vectors on them and scalars on them. I'm going to add an isosurface and finally export this model to VTFX. Finally, I'm going to share those results to create a very simple PowerPoint presentation with an interactive 3D model and also give you a sneak peek on our new one-click sharing technology, which enables you from your app to share the model on the web using a cloud service to show the model in any browser or on any device. So in order to do this, I'm going to use Qt to do the user interface. I'm going to use Ceetron 3D components for the visualization, and I'm going to use the free Ceetron products in order to do my presentation and sharing of results. From 3D components, I'm going to use the core and visualization components. Those components are always in use when you create a visualization app. I'm going to use the unstructured grid component in order to manage and create the visualizations needed for finite element data. I'm going to use the import CAE component to import the NASTRAN and ANSYS data files. This is a brand new component just released from Ceetron. And finally, I'm going to use the export component to export to a VTFX file. This compact file, I'm then going to use our free products to share to create a presentation in PowerPoint and also to upload to our cloud service in order to share it to anyone with a web browser on any device. So the two models I'm going to be using in this video tutorial are shown here. The first one is a NASTRAN model with a vibration study of the steering wheel there. And the second one is a volume element model from ANSYS, which has a flow optimization of a turbo pump. Both are around 100,000 nodes, not too large, so they're sort of convenient for this video. So let's get started. I'm going to open Developer Studio and I have created a very simple skeleton application in Qt here. You see, this is my main file where I create a Q application and a main window. And I also have the main window where the only thing I do is to create the mainframe and the layout, and that's it. So we're starting from scratch, and I'm going to show you then how to code a minimum post processor in just 45 minutes with all these capabilities we talked about. So the first thing I'm going to do is to initialize Ceetron 3D components. And in order to do that, I need to include all the header files defining the components. So there's 5 different components that are going to be used in this example. And then I'm going to do the initialization. And here I'm initializing all the components, the 5 components. The first one is the core component. You start off by initializing this, and to the initialize there you provide a license key. This license key here is an evaluation license which will expire end of May, but you can request new evaluation licenses from our website where you also download the evaluation version. When you buy Ceetron 3D components, you will get your own permanent license that you will include in your application here. And then also you'll get rid of all the license or evaluation license warnings that you will see when we export to VTFX. And then we just take this component instance and send that to all the other components. Then the only other thing we need to do in the main file here is to create what we call an OpenGL context group. The OpenGL context group enables you to share OpenGL resources between all the views and all the viewers in your application. So it's very important to create one of these and use that in every window we're going to be using the Citroen 3D components. So I'm going to start out here by creating this OpenGL context group. So I'm going to do a smart pointer because this is going to be managing this in the global in the main function here. So pointer ref to and this is in the visualization component. OpenGL context group. Smart pointer to that. We call it context group. And this is created from the visualization component. So there's a static method there, which creates my one and only OpenGL context group. Okay, so we then take this context group here and we pass it on to the main window. So I do context group get here. So now we just pass it to the constructor on the main window. We need to do that, of course, define it here. Context group. I'm going to add an include in this file for this context group, and also add it here to the implementation file, like that. Let's see if this builds. And it still does, and there's no change yet in our app. We just initialized GLView 3D components and passed the context group to our main window. The final thing we need to do in order to show something on the screen is to create a viewer. The viewer is sort of the glue between Ceetron 3D components and your UI toolkit. Ceetron 3D components is UI toolkit neutral, which means that it can run with any UI toolkit. So in order to display it on a physical window in a given UI toolkit, you need a viewer. We provide viewers out of the box for Qt, for WX widgets, for MFC, Vim32, and .NET and WPF. If you need any other or are using any other UI toolkit, you can either create a viewer yourself using our framework, or we can assist you in doing that. So please contact support if you have any problems integrating with the UI toolkit of your choice. For Qt, I'm going to use the one that are sort of provided with Ceetron 3D components. So I'm going to add my viewer now to the main window. So let's go to the header file here and create a private member. And it's CQT viewer widget demo. This is a viewer which also implements the sort of standard navigation we are using at Ceetron. You can either use this as a boilerplate and start extending it, or you can derive from the main sort of UI viewer and add your own navigation. So I'm going to call this viewer like that, and let's add an include for that as well. And then we are going to create the viewer. So we go here after we have sort of done the Qt initialization, and I do m viewer equals new, and I pass in the context group as the first param, and then the parent, which is going to be the main frame here. Main frame. Now we sort of created the viewer. Then we need to add the view to a viewer, because the Ceetron 3D components, the view is what has the camera and which we can add models to and show things on the screen. So I'm going to go to viewer, just set view in that. I'm going to just do a new view. Like that. So now I created a view. It's stored in the viewer, so I can get it from there when I need it later on. And finally, I'm going to add this viewer, which is a widget, to my layout. So I'm going to do the frame layout, add widget, and pass in the viewer. This is now managed by Qt, so I don't need to delete it in the structure or anything. If you try this now, you will see that if I run this now, I will get a blue window on my screen here. This blue is sort of the default background color of Ceetron 3D components, so this shows that, okay, we are up and running. There's still no model to show, but at least we have the viewer up and running. Then I'm going to create a very simple user interface for our mini post processor. And then first I'm going to add some includes. These are all the includes I'm going to be needing in my demo application. some from core, some from visualization, some from the unstructured grid, and some from the import and export. And also some includes I'm going to be needing from Qt. So with all those includes in place, we can add some menu entries and prepare to use components in order to open the file. So first here I'm going to add some menu entries, and I cheated a bit on this, so we just do like this, and we add two menus, one file and one model with the slots. And in Qt, these are sort of the methods that are called when the user selects the menu entry. These are methods, so I need to add them to my class here. So there, we just add the slots, which are basically just methods. And I also, in order to make this to compile, then I also need to add the stub implementations of this. So let's do like this. So now we have sort of empty methods for all the features we're going to be adding to our application. So if I run this now, you will see that I have my menu entries here now. So I'm sort of prepared to start adding all the features we need in our app. Very good. So the first thing we're going to do is to open a file. In order to do that, we need to present the user with an open dialog and select a file name. So in Qt, you do this like this. You get a file name from the standard open dialog, and if the file name is specified, then we can go on. To show the file on the screen, we need a model, and we need to add that model into the view. In this case, it's a finite element model, so we are going to use the unstructured grid model. So we go to our header file, we add another private member. I'm going to use a pointer, smart pointer here, so I can manage the lifecycle of this. And this is going to be an unstructured grid model. So we do a CUG unstruct grid model. I call it a model, and then let's have an include for this as well. So now I have my two, I have the viewer and the model, and we're ready to go. Let's just see that this compiles. Very good. Okay, we are going to use the import CAA component in order to import the results into the model and use that as a data reader, so we don't need to deal with, okay, the format of ANSYS or NASTRAN or whatever. So I'm going to use this, and let's create a data source. From the import CAE data source CAE, like that. I call it source, and it equals new, and I need to provide an ID. I just set one here, and then we're going to open the file. Source open, and provide a file name. I need to convert this from Qt to the Citroen 3D components. I have a utility to do that, to str file name, like that. And if this is open and successful, we're going to show it on the screen. So let's first create the model. CUG unstruct grid model, like that. And then we're going to set the data source in this model. So what this means is that this model is going to get all its data from this source. Set data source, which is the import CA data source that we are opened here. So this is now going to provide my model with all the data I need. So I can just specify what I would like to show, and it will read it through this data source. Okay, so, and then I need to add my model to the view. And we go here with viewer, view, and then we're going to first of all remove all the other models that are there. So if you like open a second model, we will not have two models on the screen. So we remove that model, and then we add the one we just created. Add model, and we send in the model. Get the naked pointer from that one. Now we have sort of added the model to the view, but before we can show it, we need to specify what to show. And here we are going to query the contents of the file we just opened. And all the data sources, they have a directory that contain, like, is it like a table of contents of the file we just opened. So it lists all the states that are available, all the scalars, vectors, displacements, transformation result, tensors, whatever is in that file is in the directory. This means that whenever we open the file, we don't read the whole file. We just scan it to get the metadata sort of out of it, put that into the directory so you can present that to your user. In a normal case, you will populate your UI with the contents of this directory. Here we're doing a very simple UI, so you're just going to select the first result. So I need then to get the first state ID in the file. So first state ID, and this is going to go into the source, and I'm going to go to the directory, state infos, just grab the first one and get the ID. So this is the ID of the first state in the file. If there's only one, that's the ID. In your real app, you would probably do some checking here to make sure that there are at least one state ID. In this case, I'm just assuming that. So, and then I'm going to use the model spec to specify that I would like to show this this state in my view. So I had the model spec. The model spec is a very central class because this is where you really configure what you would like to show in Ceetron 3D components. Here you specify which fringes result, which vector result, which displacement result, and so on to show, and also which state or which states if you are doing animations. So I'm going to do just set state ID here, only one because there's no animation here, like that. And then the final thing I need to do is update visualization. Whenever you change something in the unstructured grid model, you can change a lot of things, and then you do update visualization. And the update visualization is quite smart in order that it only does what is necessary based on what changes you have done since the last update. So you can call this at any time, and it will be as fast as possible, really. In order to show this on the screen, we also need to set up the camera to specify which angle we're going to show it from, and the position of the camera and the zoom factors and stuff like that. So when we open the file, we just want to create a default, sort of nice default view. And in order to do that, I'm going to look at the center of the bounding box and to fit my view around that. So I'm going to go to get the bounding box from the model, just model bounding box like that. I'm going to get and then go to the camera, and the camera is in the view, which is in the viewer. So the camera, and then I'm going to do a fit view. This sort of just say that I have a model on my screen. I would like to show it from this angle with this up vector. So I do the bounding box. I need to provide the bounding box for this. So I send in the box. I then specify my view direction, which is going to be the y-axis. And finally, I specify the up vector to orient the camera. It's going to be the z-axis, like that. And then I also would like to set a rotation point in the center of the model, so we're going to rotate around the center of the model. Go to the view, camera, we have an input handler here, which you can customize, and I'm going to set the rotation point here, just to the center of the box. Like that. And that's all really. The final thing we need to do is UI specific, and that's make the UI refresh itself to redraw the screen, because we have changed something and we need to give the UI a message to repaint the screen. So in Qt, that's just doing update. So now if you build this now, I should be ready to go with opening a file. So let's try to open one of the files that we are going to be used for this video demonstration. Let's first do the car model. And as you see here, I opened this. It was a NASTRAN result. And I have my model on the screen already. I can also then go here and open the other model, which was the vacuum pump. And you can also see this opens without problems. And with just these simple lines of code, I can open any file from any format supported by the import CAA. The next thing we're going to do is to toggle the element mesh on our model. And that is really changing the draw style of each part. So we're going to loop over all the parts here and just toggle it between surface and surface mesh. And to do that, I'm going to use a part iterator. Um, so we get the part settings iterator, we call it it, we feed it with the model like that. We do a while loop while it has next. Sorry, I forgot this. That's my while loop. So looping over all the parts. And I'm going to take the part settings and then toggle it. So let's first get the UG part settings. Settings equals it next. So I'm grabbing the part settings for the next in my iterator here. And then I'm going to change this. So I go to the settings, set draw style. And then I'm going to toggle this. So I'm going to setting draw style equals if it's surface, part settings, surface. If it's surface, I'm going to set it to surface mesh. If not, I'm going to set it back to surface. So surface mesh. If not, set it back to surface, like that. So that's basically toggling on all parts. Then we need, finally, after doing that on all the parts, we need to go to our model and do update visualization, like always, and refresh all the UI. So now we sort of, by just a couple of lines of code, we added an option to toggle the element mesh on our model. So if you open the car guy first, we can see here, let's rotate a bit, and toggle mesh then toggles the element mesh on this model like that, with just these few lines of code. Very good. Let's go on. The next thing we're going to do is to show a scalar result on the model. So I'm going to pick the first scalar result and just show it. And if there are a scalar result, I'm just going to remove it. So this is also done in the model spec in the same way that we specified which state to show. So I'm going to go here and say if my model spec fringes result ID, if that equals -1, so I'm not showing anything, then I'm going to pick the first one. So I'm going to do if just get the first one first, scalar result ID equals, we have the model, the data source, we're going to the directory, we're going to scalar result infos and just grab the first one and get the ID of that one. So that's the first scalar result available for me, and I'm going to use that. In a normal application, you will probably do a UI here with a combo box or a tree view or some other ways of selecting from showing to the user and selecting which result to show. Here I'm just going into the model and picking this first one. So model spec, set fringes result ID to first scalar result ID, like that. And if not, we're just going to set it to -1. So model spec, set fringes result ID -1. As always, we do model update visualization and update. Let's see. So now we have a way to show scalar results. Let's open our car model again and show and see what was the first result in the file. Well, it was X displacement. And you can see that there are some displacements here on the steering wheel column. We can also go to the valve, and probably it's X displacements here as well, yes. And you can see that mapped as a filled contour on the screen. The color legend here is sort of in the default configuration. You can set this up with any color scheme. You can do your own settings. You can do a continuous or a level based like we're doing here. And there's many options to control the visual appearance of the color legend and also the color scheme or the palette that's used to present this on the model. Good. So then we are going to show vectors on a model. And vectors are very similar to scalars, the way you specify them. So I'm just going to copy here what I did with fringes, and I'm going to to do it with the same with vectors. So vector result IDs, but there's a one difference, and that's you can only show one scalar as field contours on your model, but you can show many vector results at the same time. If you do, you would probably like to color them with different colors to be able to see which vector is which, but it's possible. So here I just need to make sure that if there are no vector results, I'm going to do, let's do first vector result ID. So if there are no vector results, I'm going to pick the first one. Vector result infos, the first one, and then set vector result ID to this first one. If not, I'm going to set vector result ID to -1. Update, as we did previously, both the visualization and refresh the window. Let's see if this builds. Very good. So now I'm also able to show vectors on my model. So we can, for instance, get this rocket model, toggle vectors. As you see here, if you show the vectors on the model surface, it will be shown in all nodes or elements node based on which kind of result mapping the result has. And it might get a bit crowded because this is just shown where it's defined on the model. We will also show it on cutting planes later, and there we can resample it to make it nice, a bit nicer looking. Of course, you can combine this with other settings we'll be working on already. So here we do mesh and fringes and vectors. The next thing, sorry, we're going to do is to add a cutting plane. So I'm going to position this cutting plane in the center of the model. So then I need to grab a bounding box. Like we did when we did the fit view. So to the model, bounding box, like that. Then I'm going to create a cutting plane. Cut equals new cutting plane, like that. I'm going to set the position of the plane to the center of the bounding box. We do cut, set point, box center. I'm going to set the normal vector as the x-axis to orient the cutting plane. Set normal. Let's see, make 3D x-axis. And then I'm going to specify clipping. The reason for this is that if you just create a cutting plane, it will be inside the model and you will not see it. Then you need to sort of, okay, how to solve that. There are many ways to do that. You can show the model as transparent and thus see the cutting plane inside. You can show the model as lines or as outline, or you can use the clipping features, which will clip the part of the model that's on one side of the cutting plane. So that's what I'm going to do here. So set clipping to true. Very good. So then we need to specify what to show on the cutting plane, which results to show on it. So we're going to go with cut and just pick the first scalar and the first vector. So set map scalar result ID. We go into the model, to the data source, to the directory, to the scalar infos, pick the first one and get ID. This is exactly the same as we did when we showed the results. So do the same with vectors. Set map vector results, model, data source, directory, vector results. Pick the first one. Sorry. Like that. And now the cutting plane is finished. So we add it. We take our model. We add a cutting plane. Sorry. Add cutting plane. Cut. Then we need to update visualization, and refresh the widget. So now we have added, with just these few lines of code, we have created a cutting plane with both vectors and scalars on them. So let's open the model here. I'm opening the volume element model. I go here and add a cutting plane, and as you see, I will get my X displacements shown on the surface here. I get my the first vector result, which is probably displacements. And you can see that in resampled in a regular grid on the surface of the cutting plane. And you can control the density and orientation of this grid by controlling the cutting plane's parameters. Um, Very good. So let's also one thing I would like to show also is that we can combine this, of course, with the previous visualization techniques we've added to our model. So if you go here, we add a cutting plane like that, and then we show scalars, and you can see that that matches up perfectly on the surface and on the cutting plane. We can also show the mesh. And here we see that, okay, this is showing the mesh on the surface, but it's not showing the mesh on the cutting plane. And sometimes we would like to show the mesh on the cutting planes to be able to inspect how the meshed your model inside the volume. And by enabling the element mesh on the cutting plane, you can inspect the mesh, and it will also look a bit nicer here with a continuous mesh around what we have cut out here. So let's do that. Let's go back to our toggle mesh and also toggle the mesh on the cutting plane. So I'll do a simple loop here. I equals 0, I less than the number of cutting planes in my model, like that. And I'm going to take my cutting plane here and toggle the draw style in the same way as I did with the parts. So let's get the cutting plane, OI, set draw style, and exactly the same way as I did above, I'm going to toggle cutting plane, OI, draw style equals C UG cutting plane surface. If it's surface, I'm going to set it to surface mesh. If not, back to surface. Exactly the same way as above. Mesh, if not surface, like that. So we do that, and then we do update visualization. So now I should be able also to see the mesh on the cutting plane if I enable it. So opening the model, like that. Let's add the cutting plane. Let's add the fringes first, so we have the same view as we had last time. And then when I toggle mesh, you will see that I also see the mesh on the cutting plane. And this is the mesh as it was intersected with all the elements. And you can see that it matches up perfectly with the mesh on the surface. Then we're going to add an isosurface. And isosurfaces are a bit similar to cutting planes when it comes to how we interact with them in Ceetron 3D components. So I create an isosurface, iso equals new, like that. And then I need to specify which results to compute the iso from. And in this case, X displacement is not the best one, so I'm going to select the temperature. So I'm going to set iso scalar result ID to 42, which is temperature in this model. In your app, you will probably let the user select this from a list of all the available results. I'm also going to set this to map this result on the surface of the isosurface, and I'm going to set which value to compute the isosurface from, the iso value. So set iso value to 750 degrees. And then I need to just add my isosurface to the model, iso, like that, and update the visualization, and update here. The thing is that if we do this, we will not see the isosurface because it's inside the model, like with the cutting plane. For cutting plane, we used clipping, but we can't use clipping for isosurfaces or isovolumes. So we need to do something else. And in this case, I'm just going to set the model to outline. You can also do transparent or lines or whatever that sort of removes the surface of the model so you can look inside it. So I'm just going to steal what I did for the toggle mesh here with the part iterator. Go down to the bottom here, and before we do the final update here, I'm going to do this iterator and basically set the draw style to surface or to outline for all parts. So whenever I create the isosurface, I will create it, and then I will also, in the same action, set the model, the draw style of my model, all the parts in the model, to outline. So if you try this now, we should be able to create an isosurface um, of temperature at 750 degrees. So let's open this, move it a bit like that, and add an ISO. And for some reason we didn't get the draw style. And that is because I forgot to call update visualization. So I'm sorry about that. And this shows you how important it actually is to do update visualization whenever you change something. So if I run this again, hopefully now we will be able to see that you are to see the ISO surface inside the model. There we go. So now I have an isosurface of temperature in Fahrenheit, and my ISO value is set here at 750 degrees, and you can see this nice isosurface. Um, Very good. So the final thing we're going to do before sharing our results is to export them. We're going to use the Ceetron Import Component to export to a very compact VTFX file, which we then can use in PowerPoint and on the web. So I'm going to use the VTFX exporter, and the first thing I need to do is, of course, ask the user to provide me the file name. We do that like that. And if I have a file name, then I'm going to use the exporter. And there's a couple of steps I need to go through in order to export. The first is to get the properties from my model and my camera or my view to be able to configure what to show in this file. So I'm going to create a property set collection here with my props. I'm going to create some resources. This sort of handles if your models has texture mapping, texture images on them. Let's call the images new like that. And then I'm going to use the property builder that's provided with export component. So property builder VTFX prop builder, sorry, and feed it with these two guys. So now I have my property builder ready to use. Then I'm going to add properties from my model and my view. So I go here and use the prop builder, add from model, and go put in my model. I'm going to use the prop builder, add from view, and put in my view, like that. And now I sort of populated my properties and my resources with everything that was in my model and my view. And then we're ready to export. So we go with we take the VTFX exporter, and here we need to provide the type of export we're going to do. In Citroen 3D Component, we support two major ways of exporting. One is with a full data model. So when you export, you get all the elements exactly as they are in the data source. So you get all the interior elements, you get all the result in their native result mapping or result positions, and you get basically a dump of the data source. The other kind of export is one where we take only what you need in order to recreate the visualization you have on the screen at every given time. This means that all the cutting planes and isosurfaces and particle traces are pre-computed and stored in the file already computed, and we only export also the hull of the model to keep it as compact as possible. And that's exactly what we need for our sharing that we're going to do later today. So I'm going to select the display model only. So I go export VTFX, display model only, and I'm going to send in the model I'm going to export. Like that. So now we created the exporter and we need to add our properties and our resources. So I take the exporter, I say add properties and specify the props like that, and I take the exporter, sorry, and do add resources, and let's see, image resources. And then the final thing we need to do is to export the file. So we take the exporter and we say save case. The VTFX file has support for multiple cases, and that's why it's not save but save case. So we can save several cases to one VTFX file, and we will try to reuse as much data in that file as possible. So if you have like the same model but with just different results, it will reuse the topology and the nodes of the model and only have a different scalar, for instance, if you have a different scalar result. So it's very compact, even if you have multiple cases with different part settings and viewpoints and whatever. In this case, we're only going to do one case, so I'm going to do save case. Then I need to convert my file name to, as we did with open, to as a components file, and we're ready to go. One final thing you will probably like to do here is to also add a snapshot, an image of what you have on the screen now, so which can be shown very quickly without having to read the file and regenerate everything that's in the file. And we can do that here by rendering to an off-screen image and then save that or set that in the exporter as a snapshot image. So let's do that. Let's do the pointer ref to image. Image equals new, sorry, image, like that. And then I'm going to render to this image. So I'm taking my viewer, getting my view, set render to image. And here I can specify any size. So in this case, let's say 800 by 600, for instance, and send in the image like that. I probably need to add an include for this, like that. So let's see. Now I sort of add that, and of course I need to set that image in the exporter. So exporter set snapshot image with the image. There we are. So now we should be able to export to VTFX the models we have on the screen. So let's try that. I'll open, let's take the car model first, like this, and we show it here, and we might, let's enable, let's do fringes on this one, and and mesh as well, like this. And then we export this to VTFX, and we call it car, and save, and that's done. So if I now go to PowerPoint, I would like to create a very simple presentation here to share my results and the visualization I created in PowerPoint. So here I go to PowerPoint, I create just a new blank presentation, the video demo, and then I use the Ceetron add-in to PowerPoint, which is a very easy way of inserting the Ceetron 3D plugin for Microsoft Office into PowerPoint. I'll just resize this a bit, and then I go here and I select File, and I select my car. And here you see that this is exactly the same model as I had on my screen in my app. The same viewpoint, the same settings, the same everything. And if I then go to presentation mode here, you will see that I have my model on the screen. It says demo license up here, and that's because I'm using an evaluation version of Ceetron 3D components. If I was using a proper license, there will be no demo license warning there. This is in PowerPoint, running natively in PowerPoint, and we have full speed, full hardware support of rendering, and we have, as you can see here, I can interact with the 3D model. It's no video or anything, it's the real thing. So it's the same rendering engine that runs inside this plugin as is used in Ceetron 3D components. Very well. I can also do, of course, this with another file. So let's go here. Let's try the rocket or the pump file as well. Open this one. Take this guy. Let's do all the settings we have, like that. Add a cutting plane. Okay, then we need to toggle the mesh again, and then we are going. Okay. So here now we have the visualization we would like to export as well. So we go here, we go export VTFX, let's call this pump, like that. And we go now to our 3D viewer, and I can open this file here in the 3D viewer. And this 3D viewer is a standalone application that's free to download for anyone, where you can view these multi-case VTFX files, and you can send the link to anyone, and they can download it and show it. But what's even better when it comes to sharing is to use our web sharing technology, or our cloud sharing technology. This is only a sneak peek. This feature is going to be available later this year. But by using what we call one-click sharing, you are able to take the model from your application and share it with anyone on any device who has just a web browser without installing any software. So let's try that. Let's create a model here. Let's take this my pump model, the rocket here. Let's go and select scale result and toggle mesh, so we have a nice model here. I take this, I export it. I mean, let's call it pump web, like that. So now I would like to take this model and share to anyone. When we release this, we will have a component that allows you to do that directly from your own app. So by just adding the same amount of code that you did for the VTF export, you can then push it to the cloud. In order to demonstrate that here, I actually need to open this in a special version of the 3D viewer. So if I go here, I go open, and I open the file we exported. We have it here. I just view a bit like this, and then I go here and I go send to Ceetron Cloud. What happens now, or what happened until the dialog box showed up, was that this VTFX file was sent to the Ceetron Cloud, which is running on the Amazon EC2 server. The server then produced a unique URL for me, which you see here, which is sort of the URL defining my model I just shared. So if I click this link here, it will open the file in my web browser, and I have exactly the same file as I had in my application, now running inside a web browser. And this file can now be opened on any device. I can take my iPhone, open it in Safari there, and see exactly the same model as I see here in Chrome. No plugins installed, no app installed, nothing. And I have full interactive 3D. It's the same shading model, the same shaders running in this web browser as in Citroen 3D components. I can also try this with the car model we just used. So if I then go here, open my car model again, we had this one with the mesh and some results on this as well. I can go here, do send to Citroen Cloud. It's a bit bigger model, a lot of parts, but it's quite quick. And if I open this one now, you'll see that it will sort of stream it in as it's ready. So with the mesh and everything, it streams it in, shows it as it's coming in, and I have my model here, and I can then interact with it. So this is a really powerful way of adding what we call one-click sharing. In your app, you can just have a button, say share this model, generate the VTFX, upload it to the cloud, present the link to the user, and then you can send this via Twitter, via Facebook, via email, whatever, this link to anyone, and they can look at the model on their screen. So that's all I wanted to show today. And in this video, I showed you how from scratch to create a post-processor to open several different file formats, to add some visualization features, to show results, to show cutting planes, isosurfaces, and then finally share all these results using the free Ceetron viewers and a sneak peek of our web sharing technology. If you would like to try out Ceetron 3D components, please go to www.ceetron.com/download, fill in a simple form, and you will have access to download all the evaluation versions. We have versions for Visual Studio 2010, 12, and 13 on Windows, and as well as Ubuntu and Red Hat Linux. And the Visual Studio ones runs both with C++ and C# on .NET. If you need any help while evaluating Ceetron 3D components, please do not hesitate to contact us at support@ceetron.com. And then we will try to help you through the evaluation, answer any questions, and we can also do WebEx one-to-one sessions if that's of interest to you. So that's it for today. Thank you all for watching this video, and come back to a later video.